Hi everyone, in this video I'm going to explain the least square method, a simple but powerful tool used in the building to estimate and predict cost based on past data. Let's get started. But what is this? The least squares method is a statistical technique used to find the best fitting line through a set of data points. In budgeting, we use it to analyze the relationship between two variables. For example, total cost and level of production. The main idea is to minimize the difference between the actual data and the values predicted by the line. That's why it's called least squares, because we minimize the squares errors. Number 2, the equation. The general equation of the line is y equal a plus b, x j equal a plus b, x j equal a plus b, x. Where? Who is this? Y is total cost or value we want to estimate, okay? A is the fixed cost, the part that doesn't change with the activity. B is the variable cost per unit, it changes as production changes. And X is the level of activity of production. So these equations allows use to predict future costs based on production levels.
This is the cost equation. The while is the total cost. X is the fixed cost. B is the variable cost per unit, how much cost goes up when production increased by 1. X is the production level. So, we were trying to find A and B. Let's do it. In regression, the filtered line always passes through the mean point. Therefore, when x equals its mean, the predicted value equals the mean of y. This implies a equals the mean of y, but not only under one key condition. The mean of x must be 0. If x is not centered at 0, this expression alone is not valid. Estimating the slope, b. This is the slope estimator under a special condition. The mean of the independent variable x must be a 0. The numerator is the sum of products between each while and its corresponding x. The denominator is the sum of x squared measured from 0. When the mean of x is 0, this formula is equivalent to the full least square slope. But if the mean of x is not 0, this expression does not minimize square reducing and gives blessed result. In the end, we only should to change the values in a and b in the principal expression, that is y. This is a budget worksheet that grows sales by warehouse and semester. In the semesters 1 and 2, with warehouse 1, 2, 3 in the total. In the semester 1, in the warehouse 1, we had 9% of the sales. And with it, we can see how many sales we make in percent in this semester in this warehouse. The warehouse 2 is the biggest seller with 42% of total sales. Semester 2 is the strongest period with 64 of the year. The warehouse 2 in the season 2 is the 27%, the single largest segment. The warehouse 1 is in the semester 1 has the 9%, the smallest segment. Each shall calculate the semester, the percent of semester per the percent of warehouse. With it, we can calculate the value total, where it matters. With this table, you can plan inventory, set sales, target per semester, control budget, and avoid over and understack. It's more for planning what we will make and what we will buy for this semester or month or different warehouse.
Why it's useful? In the book guiding the last squares method helps managers predict future costs accurately, separate fixed and variable components of cost, and make better financial decisions. It's a scientific and data driven way to improve budget planning and cost control. Okay, we finally have the conclusions. To sum up, the last squares method helps us understand how costs behave and give use a formula to estimate them based on activity levels. It's an essential tool for anyone working with budgets, forecasting, or cost analysis. Thanks for watching. Don't forget to like.